Good evening, class. We are looking at chapter 1, review functions and models. So there are different sections, and the sections contain 4 ways to represent a function: mathematical models, new functions from old, exponential functions, inverse functions, and logs. And here's the synopsis of that we are going to go over. So 4 ways to represent a function. We can do it verbally by a description in words, numerically by a table of values, visually by a graph, algebraically by an explicit formula. Here's the function machine. X is the input, and when we put it into the function f, gives us the output f of x, and it has x comma f of x such that x is an element of D, the domain. The vertical line test, a curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. In other words, it passes the VLT, vertical line test. A function is called increasing on an interval if f of x sub 1 is less than f of x sub 2, x sub 1 is less than x sub 2. And it's decreasing if f of x sub 1 larger than f of x sub 2 whenever x sub 1 is less than x sub 2. In other words, in the case of increasing, when x increases, so does y. In the case of decreasing, when x increases, y decreases. That's a simple way of approaching it. HLT, or horizontal line test, a function is one-to-one if and only if no horizontal line intersect the graph more than once. If two functions are inverse of each other, they're composite function, f inverse of f of x equals x. For every x in A, the domain of f of x, and f of f inverse of x is equal to x. For every x in B, that means the domain of f inverse. So their composite function is x. A function is considered to be an even function if f of minus x equals f of x, and it's odd if f of minus x is minus f of x. And as you may recall, this is an even symmetry, this is an odd symmetry, and the symmetry which is odd is with respect to the origin. We want to find the domain of the function. This is a rational function. And in short, you set the denominator equal to 0 and exclude that. So x plus 2 equal to 0, x is negative 2, so you exclude it. This is one way to represent it. With the interval notation, we write negative infinity to negative 2 union negative 2 to infinity. In this case, f of x equals 4x cubed minus 5 over x squared plus 3x minus 10. We have to do the same thing. And to do so, we are going to factor the denominator. We need two numbers. The product is negative 10. The sum is positive 3. So 5 and negative 2. If you set this equal to 0 and exclude what makes it 0, x can't be negative 5. X can't be positive 2. In an interval format, we would write the domain is from negative infinity to negative 5 union, negative 5 to 2 union, 2 to infinity. That's how we would write it in an interval using an interval format. In essence, we are going back to this question. Is f of x equals x squared minus 4 over x plus 2 equal to x minus 2? It's a rational function. And remember, even when you want to graph a rational function, the very first step is to put it in its lowest term. Numerator is the same as x squared minus 2 squared. And we can use a squared minus b squared is a minus b times a plus b, and factor the numerator into x minus 2 times x plus 2. We can cancel these two. However, the fact remains that x can't be negative 2. So that means they are the same except when x is negative 2. What is the difference? So the answer is no. What is the difference? This one is just a line, whereas this one, which simplifies to this, it's a line with a hole, because you have to exclude negative 2s. So when you plug in negative 2, you get negative 4. So negative 2 comma negative 4 would be the hole. So you plug in the number that you're excluding into the line, and that gives you the pair. And if you do so, if you plug it in, then this would be the pair that will be excluded from the line to give us this, the graph of this function. Determine whether each of the following functions is even, odd, or neither even nor odd. Definition of an even function, reminding you f of minus x equals f of x. Odd function, f of minus x is minus f of x. So all you have to do, evaluate f of minus x. So let's do that for this one. In other words, replace the x with negative x. This is minus x to the power of 5 minus x, and you can factor the x out. And when you compare these two, this is negative of f of x, and therefore f is an odd function. Part B, we are going to look at g of negative x by replacing the x with negative x. X to the power of 4 or negative x to the power of 4, because the exponent is even, gives you the same result. And so therefore, you get the same function back. And according to this definition, g is an even function. What about h of x? We do exactly the same thing, which means we are replacing the x with minus x. We get 2 times minus x minus negative x squared. This becomes negative 2x. This is the same as x squared. And as you can see, this is not equal to h of x. And it's not the opposite of that either. It makes it neither nor. In other words, since h of minus x is not equal to h of x, okay, that makes it not even. Since h of minus x is not equal to minus h of x, we conclude that h is neither even nor odd. So it's pretty straightforward. Here's the graph. Example 3, where is the function increasing, decreasing, constant? Remember the definition of increasing, decreasing in a easy manner to understand that if you assume it's a line looking like that has a positive slope, and a line looking like that has a negative slope, and a horizontal line is constant. So this part is increasing from here to here, from -4 to 0. So x is between -4 to 0, or in an interval format, parentheses -4 to 0. Normally the endpoints are not included, okay? Because at the endpoints, it's neither increasing nor decreasing. Where is the function decreasing? Going down. You can think of it as, again, let me just think about this. If you have a line looking like this, the slope is positive. A line like this, the slope is negative. So in your mind, assume it's almost a line, and you can see that versus these two. So it's decreasing here from -6 to -4. This number is -4. Union from here to here, from number 3 to number 6. Parentheses, the endpoints are not included. So -6 to -4 is this part. Union 3 to 6 is this part. And finally, where is the function constant? A horizontal line. Here's the horizontal line. So from here to here, so that means from 0 to 3, this portion. Example, for as dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of height h in kilometers, assuming that a linear model is appropriate. Draw the graph of the function. What does the slope represent? So when we want to do this, remember a pair normally we represented with x and y. But right now, because we are not using x and y, it is important to know what we need to do. So we are going to go with h and t. Why are we going with h and t? Because a t is a function of h. T, h is the independent variable, t is the dependent variable. At the ground level, 20 degrees, so the height is 0 and the temperature is 20 degrees. And at 1 kilometers, 1, the height of 1, the temperature is 10, it's decreasing, okay? As you know, the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to write this first. And using this pair would be t sub 2 minus t sub 1 over h sub 2 minus h sub 1. So I want you to see how we arrive at this. So 10 minus 20 is the numerator, 1 minus 0 is the denominator, which makes it -10. Units of the temperature over the units of the height, just units of the top over the units of the bottom. Degrees Celsius per kilometer. Because we have this one, everybody, remember we can use y equals mx plus b if we were using x and y, but we're going to use h and t. Therefore, y is t and x is h. And obviously this is 0 comma b. So this is b. T is negative 10h plus 20. As far as the graph is concerned, obviously this is the y-intercept normally, but of course now it's a t-intercept, okay? Because we don't have x and y, okay? We have h and t, okay? So x and y are changing to h and t. So the y-intercept becomes the t-intercept. So 0 tone on the one hand. On the other hand, if I set this one equal to 0, if I put 0, then h becomes 2. I hope everybody can see that. This, you're a calculus student, you can see this. So 2 pairs, 0 Tony, 2 0, and you plot this, and again, x becomes h, y becomes a t, and we don't go negative as far as the height is concerned, although we can, okay? So t is minus 10h plus 20. The slope, or m, is negative 10 degrees Celsius per kilometer. It represents the rate of change of temperature with respect to height. As you recall, slope is the average rate of change of y with respect to x. We talk about x, y, and this format. Now that we have h and t, that represents the average rate of change of t with respect to h, okay? That's exactly the same as that. We are changing just the variables accordingly. So we did draw that, and we explained the slope. And by the way, if instead of y-intercept, remember we have the t-intercept, which represents the temperature at the sea level, in essence, at the ground level, sea level. What is the temperature at a height of a 2.5 kilometers? So just this one, replace the h with 2.5. Negative 25 and 20, they add up to negative 5 degrees Celsius. When we deal with applications, we must answer with proper units always. New functions from old ones, section 1.3, transformation of functions. Just a synopsis of that, and we are assuming c is a positive number. So here's the basic function y equals f of x. Okay. If we are looking for y equals f of x plus c, again, we are assuming c is positive. We take it up along the vertical line by c units. Y equals f of x minus c, we bring it down by a factor of c. F of x minus c moves to the right by a factor of c. F of x plus c moves to the left by a factor of c. And again, you have y equals f of x. If you multiply, again, we are assuming c is positive, and moreover, we are going to assume c is larger than 1. So y equals c times f of x, it gets larger by that factor as far as the y goes up. And if it's 1 over c, it gets smaller by that factor. So it goes below that, minus f of x. So this function reflected across the x-axis becomes minus f of x, reflected across the y-axis becomes f of minus x. How do we find the domain? Using algebra function. First and foremost, algebra function. What is f plus g? F of x plus g of x. This is called the sum function. The difference function, f minus g, is f of x minus g of x. The product function, fg, is f times g. The quotient function, f over g, is f over g of x, is f of x over g of x. Needless to say, as always, class g of x can't be 0, okay? So when you look at the domain for those, assuming that A represents the domain for the function f and B represents the domain for function g, then the domain for all of these functions are A intersection B. The last, so all of them. The last one, also we exclude anything that makes the denominator 0. So for this one only, the domain would be the same as here, with the added condition that such that, this is read such that, g of x can't be 0. So I read this, x is an element of A intersection B such that g of x can't be 0. So this is read an element of. Let me write that in case. So this looks like an epsilon. In set theory is read an element of this line segment is read such that. And f of g of x is equal to f of g of x. G of f of x is g of f of x. Composite functions. All right, transformation function continues. Recall that absolute value of x is x if x is larger than or equal to 0, negative x if x is less than 0. It's important to understand the meaning of this expression. If x is positive or 0, you could drop the absolute value. If it's not, you write the opposite of that. Minus x doesn't represent a negative value. It represents the opposite, which makes it actually positive. So with that being the case, absolute value of a function y equals absolute value of f of x, where absolute value of f of x is f of x is larger than or equal to 0, and it's minus f of x if f of x is less than 0. So with that being the case, how do we graph an absolute value function? First, we drop the absolute value and just graph it. Again, remember, f of x equals x squared is a parabola that goes down by 25 units. A basic parabola y equals x squared. The next thing is this. So this is the graph of y, or f of x equals x squared minus 25. And bear in mind that this has location 0, comma, negative 25. Maybe I write that. So how do we graph an absolute value function? The part of the graph of f of x that lies above the x-axis remains the same. So the blue part, you don't have to do anything. The part that lies below the x-axis is reflected about the x-axis. So the blue part remains. The yellow part flips over, just like this, okay? So this flips over because it's negative by definition of an absolute value. So y equals absolute value of x squared minus 25. All right. Sketch the graph of the function y equals absolute value of square root of x minus 1. So what we are going to do, we are going to ignore the absolute value first, and we're going to graph square root of x minus 1. And so we start with y equals square root of x. That is one of those elementary functions. We should know the graph looks like this. Now, it is extremely important that you know the graph of all elementary functions that we have studied in previous courses. When you have the graph in your mind, you can see the domain is from 0 to infinity. The range is 0 to infinity. You can see the x and y intercept are located at 0, 0. All the information, you see the function is increasing. So the graph really makes a huge difference. Now, we are going to go with the next step and find this. To find this the same function, but it's shifted down by 1 unit. So we are going to bring this down by 1 unit. This is 2. This is -2. So 2 tick marks is 1. Okay. So we are bringing it down by 2 tick marks, which is 1 unit. All right. Now that we are done, we want to go with the absolute value. How do we do that? Well, this portion, everybody, remains unchanged. This portion is below the x-axis, so it flips over like that. So the portion above the x-axis does not change. The portion below, you flip it over with respect to the x-axis. I'm going to find the domain. F of x is square root of x. And as you recall, when we have a root function, if the index is even, we have a restriction, which means x must be larger than or equal to 0. And it gives us the domain of 0 to infinity. Let's call it A. What about g of x equals square root of 2 minus x? The same concept. Over here, we said the radicand x must be larger than or equal to 0. Over here, the radicand is 2 minus x must be greater than or equal to 0, which means minus x is greater than or equal to minus 2. And if you multiply by negative, you get x here, you get positive 2 here. Whenever you divide or multiply by negative, you flip over the sign. And the domain is from negative infinity to 2. By the way, infinity and negative infinity are concepts, you always use parentheses. That means open. That means that is the endpoint is in essence not included. Bracket means the endpoint is included. Now, f plus g of x is square root of x plus the square root of 2 minus x. If we add these two functions, this is what we get. If we divide them, we get square root of x over square root of 2 minus x. We want to find the domain for each case. Well, as it was mentioned before, the domain is what's in common between the two. And from 0 to infinity and from negative infinity to 2, perhaps if you graph, it's easier to see. For here, and let's do for here. For this one, 0 to infinity, from here you include the 0, everything to the right. For here, from negative infinity to 2, so this is 2. Everything to the left of 2. And I hope you see that what's in common, it's this area. Let me use a different color. From 0 to 2. Is 0 included? Yes. Is 2 included? Yes. All right, so that's what's in common. What about this part? This one is the same as this one. However, remember, the denominator, which is square root of 2 minus x, can't be 0. So we write x is an element of A intersection B, intersection of events, such that g of x, the denominator, can't be 0. So what makes this 0? 2. So x can't be 2. 2 is included here, and that's fine here. But here, 2 minus x, if you set equal to 0, becomes 2, and 2 must be excluded. How do you exclude 2? You use parentheses. So it's half closed, half open. And this has got to do with this part. When we say g of x can't be 0, that means the 2 that is included here can't be included here using parentheses. F of x is square root of x minus 3, g of x is x squared, h of x is x cubed plus 6, and we want to find f, o, g, o, h, the composite function of f and g and h. And you can do in a couple of different ways. You can find GOH first, then FOG of H, or you can find FOG first and then FOGOH. It makes no difference, everybody. So FOG, let's look at these two. FOG by definition is f of g of x, and that means replace this x with x squared. So you get square root of x squared minus 3. And if I want FOGOH, now in here, I replace the x with x cubed plus 6. So it becomes square root of x cubed plus 6 to the second power. And you don't have to simplify this class, okay? You can simplify it, but you don't have to. If I want to get the composite of these two first, GOH, that means I replace the x here with x cubed plus 6. And now if I want to get FOG, this x must be replaced with this, which is exactly what we got over there, okay? So both of them will result in the same thing. And as long as you understand FOG and GOH, those orders must be followed. The rest is not going to make any difference. One thing I want to add here, what happens is over here, we were dealing with an even index and the same thing here. I hope everybody remembers what we mean by index. So when I don't write the index is 2. Now, if I write, let's say y equals cube root of x, remember the domain is all real numbers. With odd index 3, there is no restriction. So odd versus even as far as finding the domain is concerned, okay? Let's remind everybody about exponential rules and exponential functions. First and foremost, the exponential rules that you see here are such as a to the power of 0 is 1, a to the power of m times a to the power of n is a to the power of m plus n. That's the product rule, quotient rule, power rule, negative exponential rule, and so forth. I hope everybody remembers that. Now, as far as the function is concerned, f of x is b to the power of x. B must be 0 and b can't be 1 for it to be an exponential function. When b is larger than 1, it looks like this, which is an exponential growth. When b is between 0 and 1, looks like this, which is an exponential decay. When b is 1, you don't have an exponential function. You have the horizontal line. So this is not an exponential function. So what do we notice? That's why it's important to remember the graph. Horizontal asymptote is the x-axis for both of these, which has the equation y equal to 0. There is no vertical asymptote. The y-intercept, both of them at 0, 1. Both of them, they don't have any x-intercept. Domain, all real numbers. Range from 0 to infinity. So what's the difference? This one is increasing. When b is larger than 1, it's increasing. That means the limit of f of x as x approaches infinity is infinity. That's the end behavior. It refers to the first quadrant. And limit of f of x as x approaches minus infinity is 0. That refers to the definition of a horizontal asymptote. When b is between 0 and 1, in this case, which is a decreasing function, the limit of f of x as x approaches infinity is 0. Again, the horizontal asymptote. And the limit of f of x as x approaches minus infinity is infinity, the second quadrant, which is the end behavior. Sketch the graph of the function y equals 1/2 e to the power of minus x minus 1 and determine its domain and range. We are going to start with the basic function y equals e to the power of x. And it doesn't have to be perfect, looks something similar to that, similar to the previous page for an increasing function, where the base was larger than 1. Remember, e is a number 2.718 and it continues indefinitely. So that's the first step. The second step is to get e to the power minus x. So we're going to reflect this about the y-axis to make it e to the power minus x. The next one is 1/2. So compress the graph vertically by a factor of 2, make it y equals 1/2 e to the power of minus x. Finally, bring this down by how many units? 1 unit. So shift the graph down by 1 unit. So bring this down by 1 unit. So what happens? First and foremost, here 0, 1, here 0, 1, those are the y-intercept, and here is 0, 1/2. And when you bring it down by 1 unit, becomes 0, negative 1/2. So it doesn't change the domain here, here, here. The domain is all real numbers. The range for all three from 0 to infinity, but for this one now from here, from -1 to infinity. So it changes the range. The domain is all real numbers for all 4 of them, in fact. The range is different. Those 3 are the same. And this is from -1 to infinity. So that's the transformation. Determine the domain. In this case, we are dealing with the square root of 10 to the power of t minus 100. Regardless of what's underneath, when we don't have the index is 2. It's an even index. And what's underneath must be greater than or equal to 0. In other words, non-negative. We can move this to the other side, becomes 100 or 10 squared. So if you compare this one and this one, and the greater than, so t must be greater than or equal to 2. What about this one? Well, if you look at the inner function, e to the power of t minus 1, you have to look for restriction if it has. It has no restrictions, exponential functions, remember. The domain is all real numbers. And sine has no restriction. So the domain is R. It's the composite function of a sine and exponential function. The domain remains as all real numbers. Solve for t where e to the power of x squared times e to the power of 2x plus 1 equals e to the power of t. Well, we are going to use the exponential rules and reminding everyone of everything that was mentioned before, and we are going to use the product rule. According to the product rule, on the left side, since the base is e, just add up the exponents. So we are using the product rule, everybody. So we are going to add X squared and 2x plus 1. Well, they both have the same base. They must have the same exponent. X squared plus 2x plus 1 must be equal to t. Find the inverse function. F of x is 4x minus 1 over 2x plus 3. How do we find an inverse function? Well, number one, we change f of x to y because it makes it easier to work with. Number two, interchange x and y. So make this x, make this y, make this y. And right here, the moment we interchange x and y, we have found the inverse. However, we don't leave it like that. We solve for y. So to solve for y, x is the same as x over 1. We do the cross product. X times 2y plus 3 is 1 times 4y minus 1. So x times 2y is 2xy, x times 3 is 3x, and 4y minus 1 doesn't change because you're multiplying it by 1. We are solving for y, which means everything involving y must come to the same side, and therefore we can move this to the right, this one to the left. And I'm interested in solving for y, so I'm going to only take the y out, and I get 4 minus 2x. Please understand, I can get the factor of 2 out also. And we may have to, in this case, we don't, we have to divide by 4 minus 2x, and that's it. The reason I didn't take the 2 out because the final result, I don't have a common factor of 2, it makes no difference. So this is the inverse. So we change the name from y to f inverse of x equals 3x plus 1 over 4 minus 2x as the final answer. Two functions are inverse of each other if their composite function is x. I'm going to quickly show one of them, f of f inverse or f inverse of f makes no difference. Let's go with f of f inverse, which means if I want to look at the composite function of these two, f of f inverse, every x here will be replaced by 3x plus 1 over 4 minus 2x, which is the f inverse. So 4 times 3x plus 1 over 4 minus 2x minus 1 over 2 times 3x plus 1 over 4 minus 2x plus 3. This is a complex fraction. To simplify it into a simple fraction, you multiply by LCD. In the numerator, there is only one denominator, 4 minus 2x. Same thing in the denominator. So multiply the top and the bottom by the denominator, which is 4 minus 2x. So what happens? If you multiply these two, 4 minus 2x goes away, becomes 4 times 3x plus 1. And this becomes minus 1 times 4 minus 2x. If you multiply these two, 4 minus 2x goes away. 2 times 3x plus 1 plus 3 times 4 minus 2x. Please understand, you have to simplify the numerator and the denominator. Nothing cancels out the way it's given. But we are going through the algebraic steps that make it happen. So, what happens here? 12x plus 4 minus 4 plus 2x. What happens here? 6x plus 2 plus 12 minus 6x. These two cancel each other. They add up to 14x. These two cancel each other. They add up to 14. 14x divided by 14 is x. And we proved this one is x. I highly recommend for practice you try this one. Logs. If b is larger than 0 and it's not equal to 1, y equals log x base b is equivalent to x being b to the power of y. If you look at these two expressions, you can see that they both have the same exponent and the same base. So let's look at this one, and let's look at the arrow that I put. So if you follow the arrow b to the power of y equals x, and if you can go from one format to the next, pretty much you're in good shape because logarithmic properties follow those. So in the case of a general case where y equals log x base b means b to the power of y equals x, we have the following properties. Log 1 base b is 0, log b base b is 1, log b to the power of x base b is x, b to the power of log x base b is x, log of x y base b is log x plus log y, both of them have base b. Log base b of x over y is log base b of x minus log base b of y, and log base b of x to the power of n is n log base b of x. So first and foremost, you should be able to see some of this stuff just using the arrow. Secondly, these two refer to the fact that exponential functions and logarithmic functions are inverse functions. And thirdly, this is called the product rule, quotient rule, power rule. When it comes to common log, the base is 10. So we don't write the base. Y equals log x means 10 to the power of y equals x. And it gives rise to the following. That's a special case. It follows. So these are the properties that I hope everybody's comfortable with that. When it comes to natural log y equals ln x, then e to the power of y is x, and we don't write log x base e, okay? And those properties, I hope you can see them. Just as an example, log 1 base b 0 becomes log 1 equals 0, and this becomes ln 1 equal to 0. I want you to pay attention to number 2 so you see how that works. Log b base b, that means if the base and the argument are the same, the answer must be 1. When we don't write the base is 10, so log 10 must be 1. Okay. When we write ln, that means the base is e, so ln e must be 1, and the rest of them follow. As an example, y equals e to the power of x and y equals ln x. The two functions are inverse functions, therefore symmetric with respect to the line y equals x. Change of base formula. Log x base b equals log x over log b. You choose the same base, for example, base a for it. However, we normally choose either common log base 10 or natural log base e for the sake of evaluation. Let's look at an example. Find the inverse function where f of x is 1 minus e to the power minus x over 1 plus e to the power minus x. Well, the process is similar to what we just did. First and foremost, f of x is changed to y because it makes it easier to work with. Next, change the y to x, x to y. Interchange x and y. Next, solve for y. So to do that, we multiply these two, so we get 1 minus e to the power of negative y. We multiply these two, we get x times 1 plus e to the power of minus 1. This one we distribute, we get x plus x e to the power of minus 1. I hope you recognize this as, for example, x over e to the power of y, or you recognize this as 1 over e to the power of y. Okay, so again, I'm going to write this. This you should recognize as 1 over e to the power of y. Okay, so you multiply both sides by e to the power of y. When you do that, here's the result. This becomes e to the power of y times x, or x times e to the power of y. This becomes x because e to the power minus y and e to the power of y become e to the power of 0 or 1. This becomes e to the power of y. Again, the product of these two is 1. So I hope you can see this. This is elementary algebra, everybody. We are solving for y, so we are going to get anything involving y on the same side, meaning I move this one this way, this one that way, and they change the sign. And on the left side, I can factor e to the power of y out, and I get e to the power of y times x minus 1 on the left side. I'm going to divide by x minus 1. I'm going to divide both sides by x minus 1. And by the way, because there are so many negative signs, if I multiply the top by negative, I get x plus 1. If I multiply the bottom by negative, I get minus 1 plus x. I hope you recognize these two are the same, everybody. You don't have to change that, but it makes it easier if there are more, there are less negative signs. So again, multiply this by negative 1, multiply also the bottom by negative 1. Now, let's go with the definition. If e to the power of y is x plus 1 over 1 minus x, what is y? You can go either with the definition, or you might say, you know what, I'm going to take the natural log of each side. And this is y, and this remains as a natural log. And we call it f inverse of x. F inverse of x is ln of 1 plus x over 1 minus x. And it will be fascinating if you can try to show this with f of f inverse equals x. Example 12, write as a single log 1/3 ln of x plus 2 cubed plus 1/2 brackets ln x minus ln of x squared plus 3x plus 2 to the second power. Reminding everyone of those properties, logarithmic properties that were discussed. Sometimes we go from left to right, sometimes we go from right to left. And so in this case, we are going to move accordingly. So if you look at this one, we can use number 7. So the exponent 3 gets multiplied by 1/3. So this, in essence, becomes ln of x plus 2. This 1/2 for this one, so I can get rid of that and put a 1/2 here. This one gets multiplied by 1/3. This one to the power of 1/2. This one to the power of 1/2. That means 2 times 1/2. And we get the following. So let's recap. This one, 1/3 and 3, that gives you 1. You don't have to write it. This one, 1/2 becomes the exponent. This one, 1/2 becomes the exponent times 2 becomes 1. Also, we notice we can factor this because we want two numbers. The product is 2, the sum is 3, 1 and 2. So x plus 2 and x plus 1. Anything that has a positive exponent, a positive coefficient remains at top. So, for example, you can combine this and put it at top. You can combine this and put it at the bottom. In other words, you are going to get ln. Just to show you these two, you would get ln of x plus 2 times x to the power of 1/2. X to the power of 1/2 is square root of x. Now, this one is minus. So that now can be combined with this using the quotient rule and going from right to left. Ln of this over that. So ln of x plus 2 square root of x over this, which is x plus 2 times x plus 1. We can get rid of that. And this is what we have as a single log. That's the final answer. It's as complicated as it gets. I'm hoping that everybody is comfortable with logarithmic properties that have been taught throughout different courses, college algebra, pre-calculus. What about this one? Well, you can combine these two. You can do it in one shot. You can combine these two into ln of x plus y times x minus y. You can get rid of the exponent, put it up here. And now, ln, again, we're going to go with number 6. Ln of the top is this, the bottom is this, and x plus y times x minus y is x squared minus y squared. So ln of x plus y times x minus y is x squared minus y squared over z to the power of 2. Now let's go back and expand it. get rid of the square root and make this to the power of 1/2. So it's log of x minus 1 over x plus 1 to the power of 1/2. Now, number 7, the power rule, put the 1/2 in front. Half of this log. Number 6, half of log of the top minus log of the bottom. So we have half log of the top minus log of the bottom by number 6, or the quotient property. Now, these are all logarithmic properties. If you feel uncomfortable with them, you got to work on those properties that have been mentioned, okay? Solve. ln of x squared minus 1 equals 3. You go to the exponential format. X squared minus 1 is e cubed. Remember, e cubed is not missing, is a number, okay? But it's an exact answer. You move the -1, that means you add 1 to both sides. And x would be plus minus the square root of the result, 1 plus e cubed. By the way, remember the argument of log must always be positive, and because it's being squared up, this expression becomes positive. You can always check it out. E to the power of 2x minus 3 to the power of x plus 2. You can do it just the way it is, or you can do it by substitution method. By substitution method, if you want to do it, you let e to the power of x be something. Y, z, m, choose any variable except x. For example, y. So e to the power of 2x becomes y squared. So you're dealing with y squared minus 3y plus 2 equal to 0. So you want two numbers, the product is 2, the sum is -3, makes it -1 and -2. So you can say y minus 1, y minus 2, and remember y is e to the power of x. So you can do the substitution, no need for that, it's up to you. So e to the power of x is either 1 or 2. In this case, e to the power of x is 1. That means x is ln 1, which makes it 0. In this case, it's ln 2. And you keep it as ln 2 because it's an exact answer, everybody. In calculus, we answer with exact answers unless otherwise mentioned. So x equals ln 1 or 0. ln of ln x equals 1. If it makes it easier in order to come up with the answer and not to get confused, you can even change this literally to, let's say, y. So ln y equals 1, and you can go with this arrow. So y, okay, y is e to the power of 1, okay? Which means ln x is e to the power of 1, or e, okay? And again, the same thing with the arrow. Or just go with the exponential format. Either way, it makes no difference. X is e to the power of e. E to the power of ax equals c e to the power of bx. We are solving for x. So we are going to divide both sides by e to the power of a bx, and we keep the c on the right. And on the left side, we are going to combine these two using the exponential rules, which means the quotient rule, which means e to the power of ax minus bx, or e to the power of a minus b times x. I hope everybody knows what I'm talking about, right? The quotient rule for exponentials. In other words, I'm using this a to the power of m times a to the power of, in this case, it's division. The quotient rule. Over a to the power of n is a to the power of m minus n. So that's exactly what we get. You can go to the logarithmic format by definition, or you can say, I'm going to take a natural log of both sides. So the left side becomes the exponent, a minus b times x. And the right side is just a natural log of c. Divide both sides by a minus b, and there you have it. ln of 2x plus 1 is 2 minus ln x. We are solving for x. Anytime you have logarithmic equations, if you have all logs, put it into a single log. And if they have the same base, they must have the same argument and so forth. If you have some logs and some numbers, bring all the logs together and all the numbers together. So we are going to move this one and make it plus ln x. We also are going to use the logarithmic properties. The product rule will become ln of 2x plus 1 times x, or x times 2x plus 1 equals 2. And now the exponential rule, the argument is base e to the power of 2. The argument x times 2x plus 1 is e squared. So this is 2x squared. This is plus x. And you move the e squared, becomes negative on the left side. And you want to solve this. Remember, e is not missing. E is a number. You have to use the quadratic formula, reminding you that ax squared plus bx plus c equal to 0. X is minus b plus minus the squared of b squared minus 4ac over 3. So what is a? 2. What is b? 1. What is c? Minus e squared. So plug in. Let's see what we get here. X is minus 1 plus minus 1 squared minus 4 times 2 times minus e squared. And I hope you recognize this one as positive 8e squared. So x is negative 1 plus minus the square root of 1 plus 8e squared divided by 4. There are two answers, one with a plus, one with a negative. We go back to the original equation. This is, the argument is 2x plus 1. This is x. And if you concentrate on this one, remember the argument must be positive. X this one says x must be positive. And remember, in this case, 2x plus 1 must be positive, which means x must be larger than negative 1/2, And so when x is larger than 0, we'll cover that, okay? I hope you recognize that this has two answers, -1 minus square root of 1 plus 8e squared, square root of that over 4, and -1 plus. If you use the negative one, it's not going to work out because x must be positive. So you can only use the plus sign because this is positive. When you take it out, it's larger than -1 and it makes the numerator definitely positive divided by 4. I mean, you can approximate, you can use a calculator and approximate it. If you use the other one, -1 minus the square root of 1 plus 8e squared over 4, you don't even need a calculator to recognize it's a negative number. We need x larger than 0. Prove cosine of sine inverse equals the square root of 1 minus x squared. Well, reminding everybody that sine inverse represents an angle or arc, and therefore if you let this one represent theta, you want cosine of theta. That's the concept. But what does that mean? That means sine theta must be x. Okay, so you're looking for cosine theta. This means sine theta is x. This is trigonometry class, okay? Inverse trigonometric functions. So we know sine is x, and we know cosine is plus minus the square root of 1 minus sine squared theta, because sine squared plus cosine squared is 1. Again, reminding everyone that sine squared plus cosine squared is 1. Is one of those Pythagorean identities. And therefore, you have two possibilities. Plus minus the square root of 1 minus sine squared, and we're going to use the positive only. The question is why? And that makes it, that is the proof. We are looking for cosine theta. The reason has to do with the restriction we put on the inverse functions. As you recall, none of the trigonometric functions is 1-to-1. And so we restricted the sign from negative pi over 2 to pi over 2. The fourth quadrant and the first quadrant. And in those two quadrants, cosine is positive. Okay, that's why you can drop the negative sign. So we prove that's the case. Simplify sine of 2 arc cosine x. Again, whether I write arc cosine x or cosine inverse x means the same thing. And that's an angle, that's an theta, if you will. So you want sine of 2 theta. So first and foremost, if we let arc cosine x be theta, by definition means cosine theta is x. Okay, so we are looking for sine 2 theta, and this means cosine theta is x. So what do we have? We are looking for sine 2 theta, and we have cosine theta. I hope you remember sine 2 theta is 2 sine theta cosine theta. So we have the cosine, we need to find the sine. And again, just like this one, that cosine is plus minus square root of 1 minus sine squared, the sine is plus minus the square root of 1 minus cosine squared. And of course, 1 minus x squared. So you can replace the cosine squared theta with x squared. So we have the sine, we have the cosine, but we have plus minus, and we choose the plus only. So 2 sine theta, we choose the plus, square root of 1 minus x squared, times cosine, which is x, which makes it 2x square root of 1 minus x squared. The question is, Why did we choose the plus only? Again, it has got to do with the inverse trig functions. Cosine also is not a one-to-one function. So the restriction we put on cosine, okay, is that between 0 and pi, we choose cosine to cover all the values. And that puts us in the first and the second quadrant where sine is positive. We want to solve the exponential functions. E to the power minus x squared is e to the power of x to the second power times 1 over e cubed. And to do so, again, reminding everybody of exponential functions, this one doesn't change. This one is e to the power of 2x. And I hope you see that is e to the power of 2x minus 3. They have the same base. They must have the same exponent. If they have the same exponent, they must have the same base. So minus x squared must be 2x minus 3. And we're going to solve this by moving things around. We are moving negative x squared to the right, so we can factor the x squared plus 2x minus 3. We want two numbers. The product is negative 3. The sum is positive 2. Those would be positive 3 and negative 1. So x is either negative 3 or positive 1. And of course, you can put it back into the original equation and check it. Nine to the power of 2x times 27 to the power of x squared equals 3 to the power minus 1. And we want to use that. So can we come up with the same base? This one has base 3. So 9 we can change it to 3 squared to the power of 2x. And this is 3 cubed to the power of x squared. So what happens is that this is 3 squared to the power of 2x. That means 3 to the power of 2 times 2x. Or 4x, and that means 3 to the power of 3x squared. This has got to do with the exponential rules. And now the product rule says I can add their exponents because we have the same base. We must have the same exponent. So 4x plus 3x squared equals negative 1. We are moving everything to the left and we're putting it into a descending order. 3 is a prime number. It's very easy to factor it. It's just 1 and 3, and 1 is just 1 and 1, both of them either positive or negative. And so when you want to write it, you write it in this fashion that this is x, this is 3x. And again, you definitely have a 1 here and 1 here, both of them positive or both of them negative. Ends up being positive, and you have to check the middle term. This is 3x, this is x, they add up to 4x. Class, this is important to be checked. The product of these two is 3x, the product of these two is x, and they must add up to the middle term. So x is either negative 1 or negative 1/3.